Hello, my name is Dave.Channin. I ride my motorcycle quite a bit, and I almost always have a GoPro camera mounted to the dashboard to record the vistas that I pass through. This is a video from a 2018 foliage trip to Maine and Canada. I am climbing Cadillac Mountain on Mount Desert Island. I like the wide-angle, high-resolution video that is captured by the GoPro. I record a lot of travel videos, and with time, of course, I forget the exact location where the videos were recorded. This is only getting worse with time. The GoPro has a fix for that in that it records more than just videos and pictures. It records a large amount of metadata that includes latitude and longitude, acceleration, and gyroscopic data. It also records a lot of details about the photographic exposure, but that interests me less. So I wrote a Python program to read the metadata from the GoPro MP4 video file and then display that information on a set of dashboard widgets that I created. For those of you with a technical bent, the program uses OpenCV and NumPy to do the heavy lifting. I am grateful to GoPro for publishing a pretty detailed description of the metadata in their Git repository. Links to these programs are in the description. My GoPro is a Hero 6 Black. I have it set to record video at 1440 resolution. The frames are therefore 1920 by 1440 pixels at 60 frames per second. Each of the metadata sensors is sampled at a different rate, so I first read all the metadata and then match it as best as possible to each frame. The GoPro sound is removed from the video. The first dial on the left is the acceleration data from the accelerometer. It's measured in meters per second squared, but I convert it to fractions of g, the gravitational constant. It has the acceleration in the direction of travel, side to side, and up-down. The latter will mostly be around 1, at least the way I ride on a Goldwing. The next dial is speed in miles per hour converted from meters per second. The third dial is the altimeter, which I tried to fashion after an aircraft altimeter. It has a thousands dial and a hundreds dial. And don't worry, it also handles over 10,000 feet for those of you west of the Mississippi. The fourth dial is the gyroscope data, which tells how fast the camera is rotating in degrees per second. Again, on my Goldwing, this is almost always around plus or minus 10 or 15 degrees per second. In between the two sets of dials is the compass heading and the bearing in degrees calculated from the most recent 2 latitude and longitude readings. Below these is the clock from the GPS, which is currently showing Greenwich Mean Time, but I plan to convert it to local time based on the latitude and longitude. The software then uses the latitude and longitude to do two other things. It gets a Google map of the location. In fact, it gets 2 Google Maps and alternates every 5 seconds, displaying a street-level map and a regional-level map. It also uses the latitude and longitude data to get Google's name for the location. This is displayed as city, county, state, and country, along with the date at the bottom of the dashboard. If you'd like me to process your videos in a similar fashion, I'm offering this as a service. Send me an email at david.channin@gmail.com, and I will send you back the details and costs. Thank you, and enjoy the video.